Hello friends, welcome back to Susan and John MathTube. So we are going to continue our discussion on Fourier series, and today we'll be learning how to transform functions into Fourier series format when we have even or odd functions. Okay, in the first part of the video we'll be discussing about the graphs of even and odd function. And once you're familiar with the graph, you'll be able to understand the properties of definite integrals which you learned in the first semester. And once you're clear with the property, you'll be able to figure out the advantages of evaluating Fourier series when we have an even function or odd function. Okay, so a function, let's say f of x, is said to be even if you get f of minus x to be f of x. So from this definition, it's very clear that a function will be even if it has the capacity to make this negative sign disappear. So one of the best examples for even function will be x square. So take a look at this. If you replace x with minus x, then our function will become minus x the whole square, and that means x square, and that is nothing but f of x. So the functions which can make negative disappear will be called even functions. At the same time, some functions will make this minus come outside. So sometimes we end up with f of minus x being minus f of x. So the best example or the algebraic example we can find is x cube. And if you have f of minus x, then it becomes minus x the whole cube, because I'm supposed to replace x with minus x. And that gives me minus x cube, and that is nothing but minus f of x. Okay, now what we do is we'll try to visualize the graphs. I'm sure you know that f of x equal to x square represents a parabola. And just now I told you it's an even function. So if you put 0, you get the output 0. If you put 1, you get the output 1. If you put 2, you get the output 2 square, that is 4. And because of the even property, when you input minus 1, you're going to get the same value. What is minus 1 the whole square? 1. And when you input minus 2, you're going to get the same value. So you're going to get the reflection of whatever you saw on the positive side. Anyway, I'm sure in plus 2 itself you learned the graph of y equal to x square, a parabola which is symmetric about the y-axis. Okay, now let's think about integration. Suppose I want to integrate from minus 2 to plus 2 the function x square. So integration means summation. Integration means addition. Integration means adding all the function values. So at minus 2 the height is 4 units. And at plus 2 also the height is 4 units. And at 1 the height is 1 unit. At minus 1 the height is 1 unit. At minus 1 by 2 the height will be 1 by 4. And at 1 by 2 the height will be 1 by 4. So what I'm trying to convince you here is this is the same as integrating from 0 to 2. Look at this. If I add all these values and double that, I'll get the same answer. You can work out and check it. So this is the property of an even function. Now let's check out one more graph which I'm confident that it's even. In your younger classes in trigonometry, you might have learned a property for cos. cos minus theta is cos theta. So look at this. It has the capacity to make that negative disappear. And as your engineering students, I'm sure you know the graph of cos x. Cos 0 is 1, cos 90 is 0, and then minus 1, and it goes like this. And the same story in the other side. Okay, so take a look at this. Cos is an even function. So this is minus 90 degree or minus pi by 2, and this is pi by 2. And you can see that if I plan to integrate from minus pi by 2 to pi by 2, I'll get the sum of all the heights over here. But isn't it same as doing this integral? That means if I add all the heights from 0 to pi by 2 and double that value, I'll get the same thing. So this is the property of an even function. Okay, now let's take a look at odd functions. First, we'll go through the function f of x equal to x cube. F of x is equal to x cube is called the semi-cubical parabola because of its shape. Because you'd have ended up with a parabola if you had some values here. But what happens is 1 cube is 1, 2 cube is 8, and we have plenty of values in between 0 and 1, and we get all the cube values over here. At the same time, because of the odd property, that means odd function means it will throw that negative outside. You're going to get minus f of x. If I integrate from minus 1 to 1, what happens is all these values, look at this, at minus 1 the depth will be 1, but in the negative direction, and at 1 the height will be 1. So basically my graph is not up to proportion, but you can imagine. So when these two function values are joined together by addition, it will vanish. Now look at this. For every value here on the negative side, let's say minus 1 by 2. So we will get the cube minus 1 by 8. At the same time, you'll get a height 1 by 8 here. So you're going to end up with the value 0. Now let's look at another famous odd function, that is our sine x. The graph of sine x goes like this. Sine 0, 0, sine 90, sine 180, and it goes like this and towards this side. And you can observe that half the graph will be above the x-axis on the positive side and half the graph will be below the x-axis. And that's the property of odd function, or it may appear in the reverse manner. It can be positive here and it will be negative here. Anyway, it's obvious if you add from minus pi to pi the function sine x dx. What happens is whenever you have a depth, you have a height over here. So the values will get cancelled. Whenever you have a depth, you have a height here. So the values are going to get cancelled and you'll get 0. So the property of even and odd function gives us an integral minus a to a f of x dx. Remember, this property will work only if the limits are in the form minus a to plus a. So if you have an odd function, the value will be 0. So remember, if f of x is an odd function, what will be the value of this integral? 0. And if f of x is an even function, what you do is you do half the integral. You just do half the integral. You're supposed to integrate from minus a to a, but you do half of that. That means you integrate from 0 to a, but double the work. So this is the property of even and odd function. Okay, now let's start with Fourier series of even and odd function. So let's start like yesterday. So consider a function f of x. And imagine this function is defined in the interval minus L to L, so that the length will be 2L. Suppose the function is odd. So suppose the function is odd. Now look at this. When you calculate A0, I hope you still remember the formula. We will end up with minus L to L, an odd function. And according to the property, what will be the answer? 0. And now take a look at an. That is 1 by L integral minus L to L f of x into cos n pi x by L dx. By the way, this is an odd function and this is an even function. When you have a product of even and odd, it will always give us an odd function. And there's a trick. You imagine odd functions correspond to minus, negative, and even functions correspond to positive. So when you multiply minus and positive, you're going to get minus. That means the product of odd and even function will give us odd function. So again, good news, the value will be 0. Now Bn, okay, so Bn will be 1 by L integral minus L to L f of x times sine n pi x by L dx. Now look at this, f of x is odd, and I told you the trick, odd function corresponds to negative, and again sine is an odd function, so negative into negative will be positive. So the product is an even function, and the property of even function is you do half the job, so you end up with 2 by L, and I told you do half the job, so integrate from 0 to L f of x into sine n pi x by L. So the news is really good. So if you have an odd function, a0 will be 0, an will be 0, bn will exist. Or in other words, your answer will be completely in terms of sine. So remember, whenever you have an odd function and the limit from minus L to L, then a0 will be 0, an will be 0, but bn will exist. But you have to integrate only halfway from 0 to L. Okay, now let's check what happens when you have an even function. You can check it out. I'm not going to explain that much. A0 will exist, an will exist, but bn will be equal to 0. You can check out, and the advantages here, you'll be integrating from, I left out one very important thing. Even functions are not going to help you. Even function and the limit should be from minus L to L. Yeah, then we will have an advantage. So look at this, a0 will exist, but we will integrate only 0 to L f of x dx. And an will also exist, that will be 2 by L integral 0 to L f of x cos n pi x by L dx. So let's try out. So let's check out one very simple problem. So are you ready with pen and paper? Okay, write the question. So the question goes like this. Obtain the Fourier series for the function f of x is equal to x. I have a very simple function here, f of x is equal to x, defined in the interval minus pi less than x less than pi. Okay, great, just great. So f of x equal to x, can you tell me whether it is odd function, or is it an even function, or is it something else? Remember, functions can be even, functions can be odd, and functions like the exponential function will be neither even nor odd. Okay, so the good news is f of x equal to x is an odd function, and I'm sure that you know f of x equal to x is a line passing through the origin and which has an inclination 45 degrees, and the usual property of odd function. Look, half the graph is above the axis in the positive side and the other part on the negative side. Okay, now the best part is the limit is from minus pi to pi. I'll repeat once more, it's very important. If the function is odd, it's not going to help you. But if a function is odd and if the limits are in the format minus L to L, then you're going to get a huge advantage. Okay, so as always, I hope you watched the first video where I explained how to find the length and how to find the Fourier series of functions, etc. etc. If you didn't watch the first video, then pause this video right now and check it out. Okay, so as always, the first thing to write is the length. So 2L will be, how do you find the length? The final point minus initial point. And we are going to get 2 pi, so that L will be equal to pi. Okay. And I'll repeat, we have an odd function and we have the limits in the form minus L to L. Wow, that's really good, because I'm not going to calculate A0 and I'm not planning to calculate AN, because I know if I calculate I will end up with 0. So the only thing I'm planning to calculate now is Bn. Okay, and we'll do that in the next page. So look at this. Let the Fourier series be f of x is equal to a0 by 2 plus sigma an cos n pi x by L plus bn sine n pi x by L. So we will substitute. What was f of x? I'll show you the last page. What is f of x? Yeah, f of x is equal to x. So I'm going to write x is equal to, what is a0? I told you a0 is 0, an is 0. So this will vanish, this will vanish. So you're going to get your Fourier series completely in terms of sine. Bn sine n pi x by L. Now call it equation number 1. And by the way, what's the value of Bn? Yeah, you do half the work, that is 0 to pi. In the question, the limit is from minus pi to pi. But I'll do the integration from 0 to pi. But I'm supposed to write 2 by L. And the usual formula, f of x sine n pi x by L. By the way, what is L? Yeah, L is equal to pi. So this pi and pi will get cancelled and we'll get something nice. So we're going to get Bn equal to 2 by pi integral 0 to pi f of x is x and sine nx dx. In the last video I told you how to integrate whenever you get a polynomial and trigonometric function. So what do you call the method? The method is called Bernoulli's rule. So Bn will be equal to 2 by pi, then you put a big bracket. So first function and minus cos nx the whole divided by n within the limits 0 to pi. Okay, and minus, what is the derivative of x? 1. And what will be the integral of the quantity inside the bracket? That is minus sine nx by n into n, that will be n square. Again I'll close the bracket and 0 to pi. I told you yesterday, don't try to substitute the limit now. The first thing you have to do is cleaning up. So we are going to substitute for x, but before that you can take the quantities which do not depend on x. So I'm going to write minus 1 by n, and inside the bracket x cos nx within the limits 0 to pi, and minus minus will be plus 1 by n square and sine nx within the limits 0 to pi. Okay, that's it. Now I'll erase the line above. So okay, so let's try it. So we're going to get 2 by pi, okay, minus 1 by n. Now look at this. You're supposed to put the value pi instead of x. So when you put the upper limit, you will get pi and cos n pi. By the way, what is cos n pi? Minus 1 the whole power n. Minus, when you substitute the lower limit, you will get 0 into some finite value, and that will be 0. Okay, now plus 1 by n square. Now look at this. You're supposed to substitute the value pi, but sine n pi is 0. And you're supposed to substitute the value 0, and sine 0 is 0. So that's it. So we end up with 2 by pi and then minus 1 by n and then pi and minus 1 the whole power n, and that will be our bn. So let's cancel these things and we get bn is equal to that will be 2 by n. I hope you know laws of indices. What is a power m into a power n? That will be a to the power m plus n. Now take a look at this. We have minus 1 the whole power 1. Minus 1 is minus 1 the whole power 1. And we have minus 1 the whole power n. Together you're going to create minus 1 the whole power 1 plus n. No, it's better to write n plus 1. So here we go. That will be minus 1 the whole power n plus 1. Yeah, that's it. So I'll write the value bn in a box. Now we are at the end of the problem. Now all you have to do is substitute. Do you still remember equation 1? Yeah, this one. But I didn't substitute the value of L. When you substitute L, this and this will get cancelled. So by equation 1, x is equal to sigma n equal to 1 to infinity. What is our bn? 2 by n into minus 1 the whole power n plus 1 and sine nx. Okay, that's it. So this is our Fourier series. And if you want the expanded format, all you have to do is you have to put the values n equal to 1, 2, 3, etc. over here. So when you put n equal to 1, you're going to get 2 by 1 minus 1 the whole square. That means you're going to get 2. You can take this 2 outside. So inside the bracket, you're going to get sine 1x by 1, and next one will be minus. Then you'll get sine 2x by 2, and then you're going to get sine 3x by 3 minus etc. Now for those who are interested, like some of you might be wondering, the left side is a line and the right side is the combination of sine and cosine graphs. So how come a line is being equated? A series means there will be infinite number of terms. Still, the line and the sine and cosine curves look completely different. So some of you might be wondering how they are both equal. So for those students, I'll show you one video clip. Okay? Once you watch this video clip, you'll be able to understand how the Fourier series creates the line. So let's watch. So this is the Fourier series of y equal to x, and you know y equal to x is a line passing through the origin and it's inclined at 45 degrees. As you can see, when we keep on increasing the number of terms, it approximately becomes that line. But the beauty is we are able to express a line in terms of sine and cos. So I hope you got a clear idea how we are able to express many functions in terms of sine and cos. And here it's a sine series. Okay, so I'm planning to stop this video right now, but tomorrow I'll explain the different types of questions which are possible for your exam. So till then, bye. And by the way, if you like this video, don't forget to subscribe